A very good morning, Varandal, and myself, Dr. K. Kavitha, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. And my subject is the electronic measurements and instrumentation. And already we discussed that in the unit 2, that is the signal generator and wave analyzer. In the signal generator, now we will discuss the pulse and square wave generator and video signal generator. Already we discussed the what is signal generator and what are the AF and RF signal generators and what is AF sine wave generator and what is RF generator and what is oscillator and what are the types of oscillators we already discussed in the previous lecture. Before this lecture we discussed the function generator also. Next, now we will discuss the pulse and square wave and video signal generator in this lecture. Okay, already we discussed this introduction to signal generator and what are the types of signal generator we discussed, and we discussed the standard AF sine and square wave generator, and we discussed the function generator. Now we will discuss this pulse and square wave generator in this lecture. Okay, what is the fundamental difference between the pulse generator and square wave generator? Okay, what is the pulse generator and what is the square wave generator? Pulse generator is an electronic, this is an instrument is used to generate the pulses and the rectangular pulses. Okay, what is the pulse generator? Pulse generator is an instrument used to measure the used to generate pulses. Pulses is nothing but the rectangular pulses. Okay, this is the pulse generator, and square generator is nothing the pulse. We are going to generate the square pulses in this square wave generator. The fundamental difference between the pulse generator and square generator is the duty cycle. Why it is the duty cycle we'll discuss later. Okay, the generators are used to measure the device in combination with the CRO. CRO is nothing but the cathode ray oscilloscope. We can't measure within only one instrument. With the help of this combination of the CRO only, we are going to generate the pulses or signals, and by using these generators. Okay, this can provide both qualitative and quantitative information of the system. Whenever the generator are using the under the test, we are going to we are going to provide both qualitative and quantitative information. Okay, next they are made use of transient response testing of the amplifiers. Okay, this is the pulse and square wave generator. Before going to this, what is the pulse and what is the square wave generator? What is the difference between the pulse and square wave generator? We'll discuss. Okay, we'll discuss later. Here we will see the block diagram as pulse and square wave generator, how it will work, how it will generate the pulse and square generator. It is looking like same as function generator. It is very similar to function generator. It is similar to this pulse and square wave generator. It's very similar to this function generator. Is a pulse and square wave generator is similar to function generator. In this half of the circuit, it is same. Here first we are giving the frequency controller. Whenever we switch on that instrument, the frequency controller which controls the frequency. Here we have to set the frequency with the help of the frequency knob. Whatever the frequency we are selecting in the in this knob, the output will get the same frequency whatever we are selecting the here. With the help of this frequency control network, it controls the frequency. Okay, whatever the frequency we are giving to the upper constant current source and lower constant current source. Then here we have the symmetry for the upper constant current source and lower constant current source. Upper constant current source and lower constant current source are used the symmetry of the circuit. This upper constant current source and lower constant current source. This switch circuit is nothing but it is acts as a switch when to switch on or switch off the circuit. Whenever it is reaches the capacitor and difference value, then it will switch on and it will switch off the. With the help of the switch circuit, it can act as a switch to switch on and switch off the both upper constant current source and lower constant current source. Now the upper constant current source and switching circuit and lower constant current source and the capacitor and the Smith trigger, these are the pulse generating the signal block diagram. This is the basic generating signal of the block diagram. With the help of this upper constant current source and lower constant current source and switching circuit and capacitor, the Smith trigger, we'll discuss later the basic generating loop, the standard basic signal generating loop. This is we'll discuss later. Then the Smith trigger is nothing but any type of that signal, the sine, square, triangular or etc. Any type of the signal that is converted into that square signal. Okay, with the help of this Smith trigger, we are going to convert any type of the input signal that can be converted into the square signal. Okay, here whenever we control the frequency, that frequency is given to that upper constant current source and lower constant current source. Here whenever the upper constant current source is on is nothing but, here for example this is the comparator. Yeah, the two input compares the two input values. What is the comparator? Already we discussed in the function generator. What is the comparator? Comparator which compares the two input signals. That is this is the capacitor and this is the reference voltage. Whenever the capacitor is the reference voltage, yeah, we are taking that 5 volts. For example, assume that the resistance value, yeah, input is 5 volts. I am applying here, and whenever it is reaches the capacitance value 5, then we are getting the output is 0. At that time the switch is in off state, and when if it is in on, if it is a upper constant current source is on state, the lower constant current source is in off state. We will discuss how we are going to generate the basic signal, basic square signal. And here if it is on, the capacitor is charges, the current is flowing here and the capacitor is charges. And when it is in off, whenever it is reaches the reference voltage to the capacitor voltage, it is in off state and this lower constant current source is in on state. At that time the current is flows here and the capacitor is going to discharges. Okay, then whatever the signal here getting, the signal here give it to the Smith trigger, that any type of that input signal that is converted into the square signal, the output, the Smith trigger output, yes, we are giving to that different amplifiers and attenuators. Here we are giving the output to the amplifier. Here we are getting the 600 ohm output and 50 ohm output. After giving that output to the amplifiers and impedances, then we are going to generate the 600 ohm output and 50 ohm output. And one more we have here, the trigger output circuit. The trigger circuit is nothing but we have the narrow on time and narrow off time periods will be there in this trigger circuit. Okay, now we will discuss what is the frequency range of this decay. Frequency range is 1 hertz to 10 megahertz frequency, and within the 7 decade steps. Okay, what is the duty cycle? The main difference is the disease variable can be with the using this symmetry. The symmetric here, the we are using that 25% to 75%. We are going to manage that upper constant current source and lower constant current source. The variable and can be adjusted to 25% to 75%. The independence outputs are, we have the 50 ohm output and 600 ohm output. When we are getting this 50 ohm output, we have that 5 nanoseconds fall time and rise time at the 5 volts peak amplitude. If we are generating the 600 ohm output, the supply pulse with the rise time and pass fall time is the 70 nanoseconds and peak amplitude is the 30 volts. Before going to this, we should know the what is the difference between the pulse and the square wave generator. Here, what is the difference between pulse and square wave generator? Here we will see the pulse signal is like that. We have different on time period and different off time period. Here the square is the duty cycle is the 50%. If we are going to calculate the average here, this is the peak value, this is the average, this is the total time period. From here to here, this is the total time period. This is the width of is the small t. What is the duty cycle is? Duty cycle of this pulse is pulse width by pulse period. This is the pulse period. This is the pulse width. This is on time. This is off time. Here nothing is generating the signal here. Here we are going to generate the signal. The 50% of here, the duty cycle is 50%. The on time and off time period. Duty cycle is pulse width by pulse period. Here the duty cycle is 50%. So this is the difference between the pulse and square wave generator. The main difference is the what are the functioning and applications are same for pulse and square wave generator. The main difference is the duty cycle is the 50% that square wave generator compares to the pulse generator. The pulse generator, the on time and off time periods are different. Okay, next we are going to see that what is the basic generating loop. Already we saw in the pulse and square wave generator. Here the constant current source and constant current source. Here we are using that already symmetry. The constant current source and follows, it is used for the symmetry of this circuit, and whenever it is in on state, the current is flows through capacitor. The capacitor is charges. The capacitor is charges when I1 is on. The capacitor is charges. I2 is in off. and it is the switch is here. This is the switch is, if it is in on state, the switch is connected to the constant current source. The current is continuously flows through capacitor. At that time the current capacitor is charges, and it is give it to that Smith trigger. Whenever it is reaches to the reference value to the, this is the comparator, we have to use that. This is the capacitance value, this is the reference value, is the 5 volts, already we discussed. Whenever it is reaches the 5 volts, then it will become, that is the 0. At that time it is in off state and I2 is in on state. Whenever if it is in on state, the current is flows here and the capacitor is going to discharges. It is taking the current and it is drawing the current, and it is give it to that Smith trigger. The any type of the input signal that can be converted into the square signal with the help of this Smith trigger. Here we are using that the ratio of this I1 here. Whenever it is in I1, if the constant current source is in on state, we will get that the positive, the capacitor is charges to capacitor value to reach the predefined value, that is the, what is the reference value. If it is reaches the capacitor values to the reference value, then the output will becomes 0. At that time we are going to discharge the current. Okay, whenever it is on, it is charges, and whenever lower constant current source is in on, it will takes the current, it will discharges the current. This is the plus I, this is the minus I. Just charges the current and discharges the current. It is charges and this is the discharges. The ratio of this I1 and I2 determines the duty cycle, and it controls by the symmetry controller. Okay, the main is the sum of the I1 I2, it will determines the I1 and I2, it determines the frequency of that signal. Okay, this is about the how we are going to generate the basic generating loop. Okay, what are the requirements of this pulse? Okay, what are the requirements? The pulse should have minimum distortion, so that any distortion in the display is solely due to the circuit under the test. Whenever we are going to generate the one signal, we should find out the some values to measure values whenever the instrument is in under test. Okay, the basic characteristics of pulse and rise time and fall time, overshoot, rising, sag, and the overshoot. Before going to this, what is the rise time and what is the fall time, we should know. Okay, whenever ideally if we are generating the pulse signal, the on time and off time is the different. Ideally, we will get the signal is like this. This is the capital T, the time period. This is the width. Is the is the on time. This is the off time period. The on time and off time is the difference. And sometimes, if the on time is more, off time is less. And sometimes the on time is less, off time is more. Okay. Then actually, practically, we will get the signal is like this. So this is the rise time, and this is the TR, this is the TF. Rise time and fall time. We are generating the signal right here. We are generating the 600 ohm output and 50 ohm output. Whenever we reach that 600 ohms, what is the voltage level and what is the on time period, rise time period, and fall time period? Already we discussed here. If we are going to generate the 50 ohm outputs, 5 nanoseconds is the rise time and fall time, 5 volts is the
peak voltage, if we are generating the signal is, the voltage is 50 ohm. We are generating the 50 ohm output. The voltage, peak voltage is, what is the peak voltage here? The 5 volts. The 5 volts is the peak voltage. What is the rise time is the 5 nanosecond and fall time is 5 nanoseconds. This is the rise time. This is the fall time. TR, TF. Whenever we are generating the 600 ohm, what is the voltage is 30 volts. The rise time and fall time is 70 nanoseconds. The 30 volts and 70 nanosecond rise time, TR is equal, TF is equal 70 nanoseconds in the rise time and fall time. Okay, this is about the rise time and fall time. When we are generating that signal, so here we have the trigger output. In the trigger output, we have the narrow on time and more off time. This is the positive triggering. If it is negative triggering, it should be like this. The narrow on time and off time, more off time. This narrow on time. This is the on time and this is the on time and off time period of the trigger. This is the positive trigger pulse and this is the negative trigger pulse. Well, this is about the pulse and square wave generators. Already we discussed the pulse and rise time, the overshoot and rising sag, and the undershoot. The pulse should have the sufficient maximum amplitude if appreciable output power is required by the test circuit, example for magnetic core memory. Then at the same time, the attenuation should be adequate to produce the small amplitude pulses to prevent over driving of some test circuit. These are the requirements of the we are going to while generating the pulse signal. Okay, this pulse and the square wave signals, that the function and applications are same, but the main difference is the duty cycle. This is about the pulse and square wave generator. Next, we are going to discuss the video signal generator. What is the video signal generator here? The pattern generators are used to provide the video signals directly by using the radio frequency modulation. By using this, we are going to test the standard TV channels for alignment, the test and servicing of the TV receivers, and the output of the signal is designed to produce the simple geometric patterns like vertical and horizontal bars and check bars and checkboard and crosshatch dots and etc. It is the multi-format, both analog and digital precision signals. Okay, these pattern generators are used for the linearity of the video amplifier adjustment. The pattern generators are these vertical and horizontal carrier cross hatches we are going to use for linearity and video amplifier adjustment. In addition to this, we are going to provide the FM sound signal pattern generators for aligning sound section at the receiver side. Next, this is the block diagram for the simplified function block diagram of the pattern cum sound signal generator. How we are going to generate the pattern signal generator and sound signal generator? Here this we will see in the block diagram. Here we have the vertical bar generator, multi vibrator divider and shaping circuit. Yeah, with the help of these, we are going to generate the vertical bars here. The help of this vertical bar generator, and here the horizontal bar generators and multi vibrator detector and shaping circuit. With the help of this, we are going to generate the horizontal bars. Here we are going to generate the horizontal bars. Whenever we switch on this vertical bars and horizontal bars, which if it is both on is in on, then we are going to generate the cross hatch and the checkerboard pattern generator. This is a cross hatch checkerboard. We are going to generate these two. If it is in on state, both are is in on, we are going to generate the cross hatch and checkerboard pattern generator. Here we have the frequency controllers is there to control the frequency, to control the horizontal bars and vertical bars. We are going to use the frequency controller. With the help of these frequency controller, we are going to adjust the vertical bars with controlling the frequency, and here also we have the frequency controller for the horizontal bars. With the help of these horizontal bars, we are going to control the frequency in the horizontal bars with the help of this frequency controller. Then both we are going to generate the cross hatch and checkerboard pattern. Here we also used to generate the blanking and gating pulse generator. It is produced by the master oscillator. The master oscillator will produce the blanking and gating pulse generator. It is give it to that vertical and horizontal bars, and again it is give it to the master oscillator is give the synchronous generator and delay circuit. That is the combination of both. We are going to generate the composite synchronous signal. The both the crosshatch and checkerboard signal and the synchronous composition synchronous signal, but both we are going to generate the pattern video signal and the synchronous adder. We are going to generate that pattern video signal with the help of this one. Okay, and one more thing we are going to generate the FM audio signals also here. Here 1 kilohertz tone frequency tone generator we are giving to that FM modulator with the help of this 5.5 megahertz carrier, and it is give it to that channel carrier to the VHF modulator with the high and low frequencies. Then we are composite, we are going to get the modulated RF output here. With modulating the sound output we are going to generate here. Okay, this is about the video signal generator, how we are going to generate the video signal pattern with the help of the pattern generator. These pattern generators provide the video signal directly. Already we discussed in the RF modulation that to test that, to design and to test the TV channels or the servicing TV receivers. What is the output pattern? The output signal is designed to produce the geometric patterns like vertical and horizontal bars and checkerboard. Already we discussed. The signal type is that this is the multi-format analog and digital processing signal. And the what is the internal circuitry in the generator? Where employs two stable chains of the inner at the multi vibrator and dividers and pulse shaping circuit, and one chain operates below the line frequency. Then it will produce the series of horizontal bars. If another operator, if it is above the 15,625 Hz, then we are going to produce the vertical bars. What is the signal modification? How we are going to modify that signal? The signals are modified into short duration pulses first, which when it is fed to that video section of the receiver along with the synchronous pulse train, and it is produced as the fine line on the screen. The what is the blank white raster? Here we are going to produce both micro H and NV switches are in off. If both vertical and horizontal bars is in off, we are going to generate the only blank white raster. Okay, if both vertical and horizontal bars are is in off state. If it is vertical bars are is in on, it will produce only vertical bars. If horizontal bars are is in on, then we are going to generate the horizontal bars. The crosshatch pattern is produced with both switches are is in on state. We are going to generate the crosshatch pattern. Okay. This crosshairs utility, these patterns is used to check the picture centering and aspect the ratio by counting the number of the squares on the vertical and horizontal sides of the screen. What is the modulated signal is the modulated picture signals are available on the limited channels for injection into that RF section. What is the audio signal? And FM sound signal with the carrier frequency. We use the 5.5 megahertz frequency and 100 kilohertz, and the modulated by it is 1 kilohertz tone, and it is provide aligned sound IF and discriminator circuit. Already we discussed that both horizontal and vertical is in off state. We are going to generate the pattern is black and white, and if the vertical is in on, horizontal is in off, we are going to generate the vertical bars, the checker horizontal linearity. And if it is in on, horizontal is in, vertical is in off, horizontal is in on, we are going to generate the horizontal bars, but application is it will check the vertical linearity. When both are is in on state, we are going to select the cross hatch, and the picture we are going to center in the picture, and the ratio to be must be adjusted if both the vertical horizontal bars are is in on state. Okay, uh, this is about the video signal generator. We'll discuss next. These generators are signal generators are completed in this unit 1. Then we'll start the what is the signal analyzer in the next video, and what is the signal analyzer, how we are going to analyze the signal, and what are the types of the signal analyzers we'll discuss in the next lecture. Thank you.